Hi friends, this video is on motion, average and instantaneous speed and velocity. This video is brought to you by COACHINGCARES.IN, Designing Future by Smart Education. Under this lesson, we'll study average and instantaneous speed and velocity both. Uh, let us talk about average speed. So, what do you understand by this term average speed? Speed we already know it's a measure of total distance covered in a given time. Measure of a distance that is called speed. So average speed is what? You can see in the picture like this car is moving with the speed. Uh, Sometimes the speed is low, sometimes the speed is a bit higher. So suppose this car is moving with a uniform speed. Say speed of the car is uniform in this. So under uniform condition we'll study the speed. Change of the position. Change of the position. Say the initial position is A and this car is moving straight line and the final position is B. So the distance, say 20 meters, and it is covering this distance in say 10 seconds. So the average speed of this car will be speed of this car will be is equal to 20 by 10 2 meter per second, and average speed of car will be equal to 20 oblique 10 is equal to 2 same. Why? Because this average speed is nothing but the total distance covered. This is a measure of total distance covered. Here you just notice it down. Total distance covered in a given time. Suppose this car is moving from this point to this point, say X, again moving from X to B. So we have to calculate, average speed. Suppose here speed is S1, here speed is S2. So we have to take the total distance from A to B. We will consider the total distance and in a given time, and we'll calculate the average speed. So here S1 is equal to S2. Both are equal because this is uniform motion. Because of uniform motion, both speeds are equal. So we'll take the average speed. Total distance is 20 and time is taken 10. So average speed will be 2 meter per second and speed will be equal to same 20 by 10. It's a speed, it's a normal speed. This is 2 meter per second. Always the graph, plotted graph of uniform motion, the graph of speed will be straight, continuous straight line. If this is time and y-axis is distance, then the graphs will come as a straight line for uniform motion. This is speed graph. Okay, so you just take care of that and always try to find out the nature of the graph and the motion, nature of the motion. Now we'll study in the second slide average speed for non-uniform motion. Now just have a look of this car. This car is coming, it is initially at rest position, then increasing the speed, and the speed is going higher Initially speed is low, then speed is increasing. Suppose we assume the car starting from A position and this car is going to the final position, but before that it is reaching position B, then finally position C, that is last position. And initially suppose car is having a velocity, car is having a speed, say 20 meters per second from A to B. Then from B to C, car is having the speed 30 meter per second. So you just observe this. This is not a uniform speed. This speed is 20 initially between this A to B, and the speed B between B to C is 30. So speed is getting changed. So this is a uniform motion of a car, and we are studying about a non-uniform motion currently to calculate the average speed. So average speed will be what? Average speed of a car is will be equal to total distance covered divided by time taken. So total distance covered, suppose this distance is 50 meters and this distance is 100 meters. So total distance is 100 plus 50 and time taken is what? We need to suppose calculate time and average speed. Sorry, we have to calculate average speed. So suppose time taken, we are taking this time for the whole journey. Say this is 20 seconds. So that will be 150 oblique 20, 7.5 meter per second. So like this, we'll calculate average speed if the object is non-uniform motion. We cannot calculate like initially taking this speed, first speed 20 plus 30. So that's not the way. So people are doing mistakes while calculating the numericals to solve average speed. So just take care of that. You have to calculate in that way. In that fashion, you have to calculate. You have to take total distance covered in the whole journey and total time taken for this journey. Okay, let us take next slide. We'll study now average velocity. Average velocity, when we talk about velocity, average velocity, so the measure of a total distance covered in a given time is called average velocity. So we'll study this for a non-uniform motion. You can have idea this is the case. This car is moving currently, with some speed V1, and the second car is moving with the speed of V2. In the same way, this is case 1, this is case 2, So in case 1, V1 is the velocity starting from the rest, car increasing the speed from point A, moving from point A, and it is reaching, say, point B. So from point A to B, suppose in between there is a point X, car is increasing its speed, its velocity from A to X, say 10 meter per second, and from X to last position B, it is reaching 20 meter per second. It is reaching with this velocity. So car is in a non-uniform motion as understood by the picture. So the average velocity will be total distance covered. So from here to here the distance is, say, 40 meters. That is 40. And this we'll calculate this 40 as the time taken, say this time taken is 10 seconds. So that will be is equal to 4 meter per second. 4 meter per second. So that will be the velocity of this car, average velocity of this non-uniform motion car. In that way, we'll calculate all the numerical problems. Now let us take one more term, instantaneous velocity. Average velocity is the total displacement covered in a given time, and instantaneous velocity is the measure of displacement covered at every instant of time. So you can understand in that way. Average velocity, suppose any object start to move from A position and it goes straight and reaches finally B position. So when I talk about this velocity of this object, say it is moving first at point X with the velocity V1, then from X to B it is moving with the velocity V2. So average velocity will be the total displacement from A to B. Suppose this displacement and divide by total time taken in that. And instantaneous velocity, we can take any instant of time, the velocity of the object. Say at this point, I want to take the velocity of this object. So that will be Vi, this one, Vi1. Suppose at this point again I want to check the velocity of this object. So at this instant that will be, suppose, AI2. So like this we can calculate the instantaneous velocity of the object at particular instant of time at any particular specific position. But average velocity at the same time is the total distance covered from A to B, the total displacement covered in a given time. So that will be the average velocity. It's a total distance in a given time, but instantaneous velocity is the measure of displacement covered any instant of time. Now some general examples we can have, suppose this boy is moving from the home reached a shop, is moving from this point and it is going to the shop at point B, starting from point A, then after taking the things going back to the point A. So here we will see, suppose this distance is 20 meters, and the time taken from A to B is say 5 seconds, no, say 10 seconds. So now average speed of the boy will be total distance covered divided by time taken. So that will be equal to 20 meters divided by 10 seconds. So that will be equal to 2 meter per second. But at the same time, if suppose I consider this journey from A and returning back to again A, so what will be the, I mean second case I take, what will be the average speed? So average speed will be total time taken, average speed, say this is 1, average speed in the second case will be total distance covered is how much? 20 plus 20, going back to the initial position, divided by time is again 20 because 10 seconds it is taking to reach the shop and going back to his home, it is taking again 10 seconds, and again this is a 20 meters. So that will be 40 divided by 20. So that will be 2 meter per second. You just notice down both the cases average speed is the same. Now we'll calculate the second case when returning back to the home, what will be the average velocity. So average velocity will be equal to total displacement covered divided by time taken. So that will be equal to total displacement is, it is starting journey from here, reaching shop, then coming back to again same position. So total displacement is 0 and time taken as we know, okay, say 20 seconds. So that will be equal to 0. So here in this case average velocity in the second case journey, this is 2 meter per second, but average velocity will be equal to 0 because displacement, we consider the displacement, total displacement in velocity case, and we consider the total distance in the speed case. So that's a major difference, guys. You can understand both the terms very clearly while solving the problems. So I hope you are now able to understand all this. So thank you very much for visiting COACHINGCARES.IN. Please visit COACHINGCARES.IN and watch free educational videos, get best quality study materials, study from the best tutors and mentors. Thank you once again.